All right, thank you, Jennifer. So good morning, everybody, and wanted to really thank you guys for taking the time to show up today and sit in on my presentation about indoor environmental comfort testing. So wanted to just start off by giving you guys a little background about myself. So I'm the Director of Engineering with Verdani Partners. We're a full-service sustainability consulting firm, and a lot of the work that we have done with MAA is basically assisting their portfolio with sustainability reporting purposes. So specifically, a lot of the work that I do is really helping MAA quantify their year-over-year energy, water, and greenhouse gas emissions. I also do a lot of technical assessments as well. Some of them include energy audits and also indoor environmental comfort testing, which I am hoping to teach some of you guys here today. So before I continue with this presentation, I just want to let you guys know that I highly encourage you guys to ask any questions. Feel free to stop me anytime during the presentation to ask questions, but I will let you guys know that towards the end of this presentation, I will have about 15 minutes allocated for question and answers. So without further ado, let's go ahead and get started. So wanted to just start off by giving you guys a quick overview of some of the topics that we will be covering. So we'll be starting off by talking about, basically an introduction. Why do we care about indoor environmental comfort testing, and what are some of its benefits? We'll then go ahead and talk about how do we determine what is a reasonable sample size? What type of spaces should I be focusing on, and how many times should I be testing these spaces? I wanted to let you guys know that in this presentation, or in this assessment, we'll be actually testing for 4 things, okay? It's temperature, humidity, carbon dioxide, and indoor lighting. And I know that we passed out some devices, or you guys should be getting them soon. And I will actually be showing you guys how to use these devices for testing, but also how to go out in the field, properly conduct the testing, and also how to properly document it as well. So that leads us to the next few bullet points here. So temperature, humidity, carbon dioxide, and illumination for lighting testing. Now you also might be wondering what happens if I get values that are outside what we consider the acceptable range or the norm. We'll also be going over some key strategies or recommendations on how to resolve these issues if you're noticing that your readings are outside the norm, okay? And then finally, we will finish off by just going over a few templates. I will show you guys a few sample templates that I actually use out in the field. And the whole point is maybe it could probably give you guys a few ideas on how you can document your own template when you're out in the field. And then after that, we'll just wrap up with a quick question and answer session. So, we'll do a brief introduction, talk about how to determine a reasonable sample size, teach you how to do the testing, how to, what to do if you're noticing that the values are outside of the norm, go through some sample documentation, and then answer any questions that you guys have. Sounds good? Okay, great. So let's go ahead and get started. So why do we care about indoor environmental comfort? And there are 3 things that I want to point out. One of them, as I mentioned earlier, is that we assist MAA with their annual sustainability reporting. And there is an assessment that they do every July called GRESB, which stands for the Global Real Estate Sustainability Benchmark. And in this assessment, there is actually a question that asks you, what percentage of your portfolio has done a health and wellness assessment? Okay? And very fortunately, indoor environmental comfort testing does qualify as a health and wellness assessment. And from my experience, a lot of the times I've seen a lot of portfolios that I've worked with have very low coverage, maybe like 10%, 20% of their portfolio has done health and wellness assessments. So the good thing is, and which is why I'm very excited to be here, is that by training you guys how to do it in-house, the whole goal is really to have you guys do the testing so that you guys get 100% coverage, which would be really great, and it would really stand out against our peers. So that's one of the first things I want to talk about, sustainability reporting. The other thing is Energy Star. Now, who here has heard of Energy Star? See a couple hands here. Okay, great. So I would say the majority of you. And you guys are probably thinking about Energy Star appliances, right? So things like, Energy Star monitors, Energy Star rated refrigerators, that sort of stuff. So what I am actually talking about is Energy Star certifications at the building level, okay? I mean, just show of hands really quickly again, how many of you guys have heard of Energy Star certifications? Okay, good, couple of you guys. So that's surprising because a lot of the times you'll think of the appliances, but for those who don't know, Energy Star certification was something that was developed by the EPA. Basically what it does is it analyzes your building and lets you know how energy efficient your building is. So it goes from a scale of a 1 to 100, and of course the higher or the closer you are to 100, the more energy efficient your building is. And they'll look at different things, like they'll look at your utility bills, your energy consumption. They will look at things like how, the size of your building, what type of building it is, your location, that sort of stuff, and compare your building to its peers and rank you based on all those attributes I just described. And if you are able to score a 75 or a higher, then what that means that you are eligible to apply for an Energy Star certification. Now you might be wondering, what does this have to do with indoor environmental comfort, right? What does this have to do with the testing we're talking about today? Well, the reason why you want to care about this is because MAA has a goal to eventually get most of its buildings Energy Star certified, but in order to do so, it must do indoor environmental comfort testing as a requirement for the testing, okay? So we have sustainability reporting and Energy Star certifications. Who here can tell me what is the most important thing that we are missing here? Anybody? So the answer is actually indoor comfort for occupants, right? That's the most important thing we care about. There's been tons of studies that have shown that people who feel more comfortable with their temperature, they're getting enough outside air ventilation, they're comfortable with their lighting. There's been a lot of studies that show that they are generally more productive, they get better sleep, they're healthier, okay? So let's look at a few studies here. So one study has showed that work performance has been estimated to decrease by roughly 1% for every degree Celsius deviation from the optimal temperature. Lowering the percentage of building occupants dissatisfied with indoor air quality by 10% has been predicted to increase work performance by roughly 1%. Doubling the outside air supply rate by increasing ventilation has been estimated to increase office work by about 1.5% and reduce the prevalence of sick leave by roughly 10%. Last one here, studies show that bedroom temperatures are often too high and air quality is often poor due to inadequate ventilation. These conditions were shown by multiple studies to reduce sleep quality and next day performance. All of these studies were conducted by the International Well-Building Institute. So basically, what these studies are showing is that when people have good indoor environmental comfort, they're getting good outside air ventilation, they have good lighting, and they feel comfortable with their room temperatures, they're ultimately going to feel more productive, get better sleep, and basically happier. And that's the most important thing, because if you have happy occupants, what does that mean for your building? It means that it has a lot of benefits for your building because ultimately it helps with retention, market value, that sort of stuff, okay? So these are the reasons why we care about indoor environmental comfort. So now that we've covered the benefits of doing indoor environmental comfort, let's talk about how you determine a reasonable sample size, okay? So in order to determine a reasonable sample size, we want to use a rule of thumb. I typically go with about a 10 to 20% rule. So let's go through a few examples. For example, if you have a 10-story building, I typically just test for 1 to 2 floors, okay? That's about 10 to 20%. If you have a garden-style multifamily campus, it gets a little bit more complex. Say you have 20 buildings, do 2 to 4 buildings, okay? And that would satisfy a 10 to 20% rule. You also want to keep in mind that you want to focus on regularly occupied spaces. So for example, if you will want to avoid places like a storage closet, a mechanical room, a trash room, things like that. Instead, focus on like private offices, areas where there's high density, a lot of occupants occupying the space, like a break room, perhaps a property manager space where like a leasing office, lobby. Things of that nature are what you want to focus on. And specifically for multifamily properties, a lot of the times you cannot just barge into a residential unit and start taking readings, right? That's sort of an invasion of privacy per se. So I would say multifamily properties just focus on the common areas. And you also do want to focus on a diverse range, of regularly occupied spaces. So, for example, I wouldn't just focus on, doing a testing for, a private office. You maybe want to get one reading in a private office, one in the lobby, one in a corridor, so that you have a large sample size, a very large diverse sample size in order to, conduct these types of testing. So, here are just a few examples of things that you can test. Private office, a spot measurement in the gym, and perhaps a lobby space or reception area. Okay, so these are just some ideas that you can think about. So now that we've talked about how to determine a reasonable sample size, let's go ahead and talk about the testing itself. So one of the devices that I highly recommend is this device right here. It's an environmental meter manufactured by X-Tech Instruments. And the thing I like about this device is that it could test for 4 things, okay? Temperature, humidity, lighting, and air velocity. And it's relatively cheap as well. So for the purposes of our assessment, we're really focusing on 2 things: stripe bulb temperature and relative humidity. Anybody in this room can tell me if they have heard of these terms or are familiar with them? Okay, none of you? Okay, well, it's really basic. Dry bulb temperature is basically, say you have a thermometer, you go outdoors and you take a reading, that's going to be your dry bulb temperature, whereas relative humidity is basically, think of it as, in this current condition, in this current temperature, how much water vapor is in the air. So we're not really focusing on, testing for mold or stuff like that. It's really focused on relative humidity. And the standards that we're trying to test against is ASHRAE standard 55, which is for indoor comfort. And their acceptable readings are generally between 68 to 78 degrees Fahrenheit and humidity levels between 40 and 60%. So you kind of want to keep this in mind. If you're seeing anything that's significantly off, it's probably something that you definitely want to note. It's also important to note that if you see any occupants that are using things like personal fans, space heaters, or if they've significantly altered their thermostats, these are definitely things you want to note because it's a sign or indication that their current room conditions are probably not being satisfied. So it's definitely something you want to look at. So let's look at this video right here. So I just want to point out that this device, it's really simple to use. You would just press the power button here. There's a function button which you can toggle until you see the RH mode, and that's where it will give you your relative humidity and temperature. And when you do the test, you just want to stand in the middle of the room, hold the device maybe like 3 to 6 feet above the floor, and wait for the readings to stabilize. And then once you have that done, you will go ahead and record the value onto your sheet. Okay. So you can see I'm actually, this is how it looks like. Press the power button, let it warm up a little bit. And then I'm going to go ahead and test the function button. And then you just keep pressing it until it gets to RH mode. You see relative humidity here, temperature. If you want to toggle between Fahrenheit and Celsius, there's a button down here that does that as well. So you would press that. And then after you're done, just go ahead and hit that power button. Okay. And I know you guys have your devices handy right now, so maybe towards the end of this presentation you can give that a shot. Now, carbon dioxide testing. We base this off of ASHRAE 62.1, okay? And there, according to ASHRAE 62.1, what you want to do is, what we're going to do is focus on taking direct measurements indoors, okay, for CO2 measurements. So before you do any testing, what you want to do is go outside and get an ambient reading, okay, of the outdoor condition. Typically, you're going to see things, readings between 300 to 500 parts per million. And the key here, according to ASHRAE 62.1, is whatever you measure indoors cannot be over 700 parts per million above what you get outdoors. Does that make sense? So let's think of an example. So for example, if we were to go outdoors and we got a reading of 300 parts per million, we do not want to get a reading above what indoors? Anybody? 1,000 parts per million, right? Because we have 300 plus 700. So that's very important to keep in mind, okay? readings in a space should be no greater than 700 parts per million above outdoor air levels, okay? So just, yeah, definitely keep that in mind, and it's a, this is what you want to do. So if, one time I was doing a measurement in an office space, and actually one of the tenants, I believe I went in during their lunch hour, I would get readings that were like, 1,200, 1,300 parts per million. But, typically you're gonna see in a lot of office properties readings in the range of like 600 to 700 parts per million. Now, in this video, I'll show you really quickly how to use this device. So you want to press that orange power button, and generally you want to give it about 10 minutes to warm up because the sensor is very sensitive, okay? But, since we don't have 10 minutes to spare, I'll go ahead and just continue with this. So there's an alarm button that you can shut on and off. And again, once the readings stabilize, you can, it will show you the value right here in parts per million, okay? And once you do get a stabilized reading, go ahead and record it, and you can go ahead and shut off that orange power button. Okay, so we have a pop quiz here. Probably just skip this part for now. You guys can do the pop quiz later. But illumination testing, wanted to talk about that. So the good thing is you can still use that same instrument I introduced earlier. And the standards we're going to follow here is based on the ISNA standards, which stands for Illuminating Engineering Society of North America and their lighting handbook, okay? Now you're going to measure in units of foot candles, which basically represents, light intensity, the amount of light that lands on a surface. You'll also notice that there's a difference between horizontal and vertical lighting that you can measure. So just to explain the difference, horizontal lighting is basically anything that lands on a horizontal surface, for example, a desk, and a vertical is the same, but anything that lands on a vertical surface, so for example, a wall, okay? So for the spaces that you will mainly be focused on will be office spaces. So if you're going into a multifamily area, focus on the common area spaces. They have measurements or recommended readings for lobbies, reception areas, stairways, restrooms. If you want to do a leasing office, then you have these private offices as well. Now you might be wondering, okay, well these are the recommended levels. Obviously they're not going to be spot on. So what do you consider something that should be noted? Well, according to ISNA, multiple dramatic differences between the actual and recommended illuminance would basically be a deviation of about 30% or more, okay? So I would say, for example, if you are looking at a meeting room, its recommended reading is 30-foot candles, then 30% of that, okay, think of it as a third, okay? So let's say 10-foot candles. So what that means is we're looking at a range of 20 to 40-foot candles, okay? So anything between 20 to 40-foot candles, I will consider reasonable. What we don't want to see is anything, like maybe a 5-foot candles or 80-foot candles. If you see things like that, that's something you definitely want to note. So anytime you have dramatic differences between the actual and recommended illuminance, definitely do note that, okay? Let's look at this really quick. So again, we're using the same device. Press the orange power button, let it load up, and then same thing as temperature and humidity, you would basically press the function button until you get to light. Once it gets there, you would want to turn the device 180 degrees, and then over there you can get your readings, and you could toggle between foot candles or lux readings, which is basically the same thing. Both of them measure light intensity. And I wanted to mention that before you actually do the testing, you do want to calibrate it to 0. So in order to do that, you want to cover the light sensor and just touch that unit/0 button until it hits 0, and then it's calibrated to 0, okay? And then once you're done, press that orange power button. So pretty straightforward, and I know you guys have it on your desk, so you can play around with it. Towards the end, I'll come around and answer any questions. So the big item is, what do you do if you are getting readings that are outside the acceptable range? Now, I do want to point out that the true intent, so we've looked at two standards here, ASHRAE and ISNA. The true intent of both of them ultimately comes down to ensuring that the occupants are comfortable, okay? So a lot of the times when I'm out on site, and if I do get readings that are outside the norm, I simply just conduct a property survey. I'll ask the occupants, I'll ask the property manager if they've noticed any, complaints with lighting, temperature, things like that, or if they notice any discomfort. And as long as they are happy, honestly, that's the whole intent and the ultimate goal of these two standards. So if you do get readings that are outside the norm, make sure you definitely do survey the property manager or the occupants. Now, the other thing that I wanted to point out is that for carbon dioxide, you would take that same approach. But before you actually do start to conduct a survey, you definitely do want to work with a building engineer to see if there's any issues that are causing those high CO2 levels, okay? A lot of the times when I do site visits, I've noticed that filters are super clogged, to the point that they're almost solid. There's windows that are not operating. Sometimes the outside air fan is shut off or the damper is completely closed. So things like that you probably do want to note or investigate at least with the property management team in order to resolve those issues. And ultimately, the only time I would say where a property would fail the indoor environmental comfort test is if you are both getting unacceptable measurements and the tenants are obviously not comfortable and they complain and the property management team refuses to do anything about it. Well then that's really not it really can't comply with an indoor environmental comfort test, obviously, because both they have high readings and obviously the people are uncomfortable and they the management staff is not willing to do things to make them more comfortable. So that is really the only situation where you would probably fail the exam. I have not encountered it yet because a lot of the times when there is an issue, it would be fixed long before I even conduct a site visit. So something you definitely want to keep in mind. Now, just to wrap things up here's just a few examples of some of the documents that I use. So, you've probably noticed that I've said, I know there's a video training out there that as well that I've sent to you guys that I repeatedly say, make sure you document things like your location, space function, date and time, specific location, your values, and any notes or observations. So, you guys have copies of the slides, just take a look at this and let me know if you have any questions, but this is basically how I document it, and I highly recommend you model it off of something like this. So, wanted to thank you guys so much for your time. I know you guys probably do want to have some time to play around with those devices, so at this point, I'll be happy to take any questions, and I'll be going around the room to help you guys learn how to use these devices.